Okay, good morning. 25 minutes, right? Okay. Okay, I can be reached at either the addresses below, one forwards to the other. You can guess which way it goes. All right, so the main point, as in it's not the crypto that's going to be the weak point of your security. If you're an open source crypto project, it's not the crypto that's going to kill you or the project. The project will die for other reasons. My main point here in the talk is to talk about how OpenSSL came back from the dead, and what some of the reasons were and what some of the pitfalls we encountered, and hopefully how the rest of you can avoid them. The history of OpenSSL can be divided into a few historical eras, Pleistocene, Macedonian, whatever, and I'll go over each of these in the next couple of slides. SSL EAY. There's various creation legends about how it came about. These both happen to be true here. Eric Young, EAY, hence SSL EAY. Hey, I've got a DES package. It was a lot of parts of it were written in assembler on the most common x86 platforms. It was the fastest one around. It was adopted into Kerberos or other people's Kerberos implementations. And I've got this big number math package. What should I do with it? His colleague, Tim, said, hey, let's do SSL. It's this new security protocol out of Netscape. And that's how it happened. It was two guys in the garage. More importantly, it was two guys in Australia, which was free of the long arm of US government export regulations and patent office. There were a small set of folks sending in patches. Groups I worked with at the Open Software Foundation, OSF now stands for something else, did it. There were a handful of tests, minimal functionality. You sort of had to run them by hand, but it worked. The next era was OpenSSL, the rise of OpenSSL. Tim and Eric got day jobs, so they were going to have to leave the package for various reasons. A new group started up. There were about many as a dozen members, folks, some key with Apache. A major motivation was export control again. Stay away from the US. We have seen, so this is another instance where short-sighted US rules hurt security, right? At one point, the team was scared to even land on US soil, okay? Active mailing list, they still took patches. The quote on the bottom here was typical of what you'd see in the real world or the IATF world. The actual quote I had started out with the letter F --, but we have a code of conduct and I was advised not to use profanity. We OpenSSL. The fall of OpenSSL. The project was moribund. Releases were not pre-announced. There were no documented policies. The source code was complex and arcane. If you looked at it, it would make your eyes hurt. The braces, I thought nobody else coded this way. It turns out it's a style called Whitesmiths, I think, Wikipedia claims. The code was complex and arcane. Everything was done via tables of dispatch function pointers. A lot of it still is, not all of it, but a lot of it still is. And you just looked at this code and it looked like nothing else you were ever used to. It was hard to maintain. The policy of SSL EAY and OpenSSL was, for a long time, if somebody gave me a patch and it didn't break my system, we'd take it. There are seeds for a big failure in that philosophy, which we will talk about on the next page. It was hard to contribute. US export regulations again. Interesting story, asked me at lunch sometime how my contribution to OpenSSL ended with me being on an ISIS kill list. Honest story. The main developers were overworked and overcommitted. This was over a course of a period of years. The team dwindled down. Some folks went on to other projects, as to be expected. Some folks, day jobs got more involved, as is to be expected. And the two core developers, in order to make money, they did a lot of FIPS work. Being able to get FIPS certification, I guess it's actually called a validation. Forget, doesn't matter. They had to take on this work. FIPS validation is important. to a large number of people. They want to be able to use crypto, and they would like an open source package. The open source code was a nice, the first open source validation. It was a key thing. It took a lot of changing of people's mindsets to understand how I could validate a package, validate a clump of software, as opposed to validating a hardware token. But it happened. It's still going on. It's just stopped right now. It'll come back. The project donations were minimal. I don't know who wrote that expression in I know who wrote that expression in parentheses at the bottom of the page. It was my native English-speaking Aussie friend, under $2,000 a year, right? As opposed to sub-USD 2,000 per annum. So very minimal communication. So we have, the origin, the rise, the fall. This is what the thing looked like. This is all, the top line is the history of all commits within OpenSSL from the beginning to now. And the highlighted graph there shows the 2 years before the event. I owe my OpenSSL career to the event. And you look at it, and Steve Henson, 448 commits over a 2-year period. Andy Polyakov. Steve was the main developer of and took over the maintenance of the protocol code, the ASM1 code, all sorts of things, the FIPS architecture. Andy Polyakov, .asm, is an assembler whiz. People from Intel would send him optimized and tuned versions for various crypto algorithms using the latest Intel assembly language instructions, and he'd send them back optimized versions. He would also, because we were all in awe and nobody could read the code, if you look at the Perl ASM stuff, again, catch me during the week, you'd see what looked like a Perl script generating assembly code, and then you looked and saw that each operand was actually a subroutine call to actually generate the real code. It's pretty obscure. There were occasional bugs. But anyhow, if you look at that, that averages out to, barely a commit a day. So what happened? Why was this fall? There was a long learning cycle to understand the code. Everything was done via an extra level of indirection. For example, the threads package, originally done by my team at OSF, was ultimately implemented as a runtime callback thing. It wasn't part of OpenSSL, but you could create all these callbacks and at runtime say, here's the callbacks mapped to pthreads, and that persisted for a long time, kind of stupid. Or the error system. Here's the callbacks that implement the error codes. And if anybody else wanted to implement their own package and storage of error codes, they could do that at runtime. Similarly for malloc, right? So everything, that's how I talked about, there was tables of function pointers. It was way too much to understand. You'd sit there and trace through all the way, and you go, well, I think SSL3 server handshake is the function I want, but then I got to find where it is in the right place. The group needed to get consulting dollars, FIPS work, to keep the project alive. Otherwise, these guys would be out on the street or mother's basement or whatever it was, right? No time was spent on building the community. Not very little. There was no time. There was no ability to make, announce, and to keep to any kind of plans, right? You hear a notice that says, okay, we got the latest release of OpenSSL is out, it fixes these vulnerabilities. With absolutely no notice, no idea these are important. You have to go track down and read everything. No idea when the next release is coming out. Those in the early days, who waited for a year for SSL EAY 098 to become OpenSSL 1.0.0. But all of these things added up to a stay dark attitude. If I don't tell you anything, then I can't, or promise anything, then I can't be held to account if I don't make the deadline. And also, because I don't know where my next paycheck is coming from, I don't know what the deadline's going to be. Okay, the CVE that must not be named. Right. In other times when we've given earlier versions of these talk, we ask people, who knows what 2014-0160 means? A couple people might raise their hands, right, because we're an OCD kind of numbers-oriented field. People do know what April 3 means, right? Rekey the entire internet. There are a couple things that were noticeable about Heartbleed. One, it was a ridiculously simple bug, right? You sent a ping packet, and you said how many bytes to send, and it should have been how many bytes were sent, but it wasn't, so the server would just send whatever data happened to be there. It was the first real security CVE, well, first real CVE that had a logo, a name, and that made the mainstream press. I don't know who Riva is, but I think the industry, she's probably moved on, but the industry has not yet fully moved on from Heartbleed, right? This is the Daily Mirror, a fine Fleet Street publication in the UK. Oh, she was okay, she was shot? Okay, shot and killed, okay, so, all right. All right, well, I'm glad, I hope she finds peace. No, seriously, man, that would stink if you had to see your daughter. Anyhow, but the fact that it made the mainstream press made everybody more aware. People were getting calls, oh, changing my passwords. There were plenty of other front page headlines. The last front page headline, I think, was when the New York Times above the fold talked about the Blankenbacher attack. But more importantly, the fact that it had a name was really useful, because you could say Heartbleed, shell shock, poodle, and it's a lot easier than having to translate to a name. If I said CVE 2014-0150, maybe I had it off by 1 error, but maybe I meant something else. So that was really useful. It also gets really tedious because then you got to get the domain name and you got to get a graphic artist, or Microsoft Word art to create your logo. But the name is useful. Okay, I encourage researchers to come up with names, not websites and logos. And the folks at INRIA are really good at coming up with names for use. Okay, recovery. So now we enter the post-Heartbleed phase, PHB. The core infrastructure initiative was created. It was created both because of the OpenSSL Heartbleed bug, and it has also funded and supported OpenSSL very well. So it's sort of this mutual synergistic thing. We are both the progenitor and the poster child for what can happen when things are done right. Donations jumped. So we had 4 funded staff members now. They didn't have to do FIPS work. They didn't have to go out and stand on the street corner and go, crypto code, crypto code. 6 months later, so about 4 months after Heartbleed, I was invited to join the dev team. In October, we had a face-to-face meeting funded by the CII. This was really, really important and useful. And so one of the lessons is try to get your dev team together. We are still geographically dispersed. Australia, Boston, New York area, and then scattered all over Europe, right? I'm American, sorry, Europe is just one place. But we did a lot of important things. A lot of us centered around governance. We wrote a release, we came up with a release policy. We came up with security policies. We posted them on the website. We came up with a coding style. At this point, you can't quite tell in the room there, but we had like 12 people in the room for 3 days, and we managed to come up with a consensus as to where to put the curly braces. That's freaking amazing. We socialized. We went out for beers. We sat at the table next to Linus Torvalds, who always kept his back to us. We don't know if that meant anything. Poodle helped. At the 3rd day of our face-to-face, the Poodle vulnerability was disclosed because someone jumped. Notification that there was this thing and someone else reverse engineered and figured out what it was, so it went out a week before we were expecting it to. And so if you got a bunch of people in a room, it becomes all of a sudden now a war room, where you're working and trying to get the secure fix out and make it as good as possible. That also helps. So having a beer helps, having a crisis to address helps, just being there in the same area helps. I'd recommend the beer over the other 2. Going to meetings is part of recovery, right? Anyone who's been involved in a 12-step program knows you got to keep going to the meetings. So keeping up the cadence. We met again last October, 2 years later. Now there was a lot of discussion. We had a bigger agenda. Still haven't published all of our notes and conclusions. Some of them are on the blog. We spent a lot of time going over the CVE notification process. If you have your own list of who to notify or pre-notify for CVEs, everybody will want to be on that list. It's really, really hard to come up with a bright white line to separate those who get to know from those who don't. We empathize with those who don't get to know. We use the Linux distro mailing list, right, maintained by SonicWall, because what we want to do is feed the top stream and then feed out. We also allow, in many cases, employers of team members to have advanced knowledge. Not always. Okay. We had a lot of discussions about and with the CII and the Linux Foundation. The Linux Foundation is the secretariat and runs the CII. We discussed how to grow the team. It's really important to us that we get more, we seem to have a sense of vibrancy going on now, and it's alive. We want to grow the team. How can we get more testing? That's actually, now that the code seems to be A, in good shape, and B, we have a plan for keeping, how can we get a better testing scheme? Nobody wants to write tests. The one place I've seen it is in Japanese companies where they feel happy when they found a bug because their test found a bug. Yeah, well, nobody. We've updated the roadmap and platform docs, and we're working on a regular release cadence. That's informed by the release process and calendar of what we think large enterprises and various other organizations do. Part of the reason for doing this is we want to get people off the old releases. We want to be able to make it a planned thing. So more transparency, have more beers, and try to make things predictable, right? Predictable, expected, not surprising. Boring is a good word. Okay, transparency. As I said before, for a number of years, you'd post to the mailing list, and maybe another mailing list poster would respond. Maybe somebody, if you've been around for a while, maybe somebody on the team would respond. But transparency is really, really, really important. Building community, document what we do, how we do it, why we do it. The website was overhauled. It's still got way too much words on it because the initial authors of that content were Swiss and German, and their language is much more formal, particularly when they're writing English, than, say, mine. They won't let me put F-bombs on the website, but, I would. The mailing list removed. Why is this interesting? Because we were previously using something called Major Domo, which was created in the 80s, not Mailman, which everybody else uses. We sped up the RT approval process. We have multiple moderators, and then ultimately we killed RT because nobody really uses it, and it's just bad. But we started, I think, a virtuous cycle. When a project isn't a black hole, people contribute. When people contribute, they see the project isn't a black hole, and you get this really nice feedback loop. Code quality, another part of the recovery. Appearances count. We have almost repeatable code reformatting. Amelia on our team is trying to get that to happen, where every check-in could be, you'd run the reformatter and you'd get the same thing. Mandatory review by a second team member. The reviews vary from, yeah, okay, like if somebody posts assembler code, I'm like, yeah, sure. For IBM said it works on their platform, great. Here's this, I don't know System Z assembler. I'm never going to know System Z assembler, but sure. So we have sometimes where it's done pro forma for process, sometimes where people get really down and into it. Now that we're doing everything on GitHub, we are starting to see more people from the outside community involved in the team's pull requests, which is good. We're still working to improve. The quality of our reviews isn't great, isn't as good as we want it to be. That would have caught Heartbleed, right? That will actually take it. That's the first part that would have caught Heartbleed. We're doing more tests. We run coveralls as part of a regular continuous integration. Oh, we have continuous integration now. We had a build farm maintained by a guy at Cisco. We have Travis. They've upped our quota so we can do more builds. One of the nice things about OpenSSL is when you go to a provider and you say, hey, would you give us free something? they tend to say yes. So our thanks page has a lot of people, Akamai CDN, rsync.net backup, Travis increased build things, Amazon Web Services, CPUs to generate more fuzzing data, and so on. So if you have something that you think could help OpenSSL, see me. If you don't have hard gold, sacks of gold, give it to RWC. Computing facilities, talk to me. These are all modern practices, but remember, OpenSSL is old, right? It goes back to the 90s. It's no longer a dumping ground for everything. As I said, the policy was, oh, if you gave me a patch and it didn't break the system that I was building on, okay, we would take the patch. Don't do that anymore. We are removing old weak ciphers. We've moved the GOST Russian cipher out to a separately maintained engine and so on. Most structures are opaque. I'm going to have to talk even faster. I'll skip the recovery. The one thing, the tools are not as great as they should be. Somebody changed the shell script to remove 10 lines and the code coverage went down. A config shell script, I don't get that. We went through all of our RT tickets. This is post-Heartbleed. The first big drop is when we closed off a whole bunch of bugs. The second big drop there is when we said, look, anything more than 2 years old, we're just not going to get to. We sent mail to everyone, told them we're closing, each person told them we're closing it, reopen it. Everything's done on GitHub now. So what's happened on GitHub? Here's the metrics that Kenny had asked for when I first submitted. Almost 4,000 commits this year. We have about 430 users, thousands of forks, I think like 2,000. A lot of new issues. We've put out 3 releases on the mainstream. One was a bug that we didn't check. We introduced a bug in fixing B, so we had to put out C. Pardon me, put out C. 12 releases on 102. 101, we put out the last release, and it is done. We understand long-term support issues. We created 102 as a long-term support issue. But we got paid to fix some CVEs in 098, but they're never going to appear on our website. CVEs, we had 9 high. A high one forces a release. 20 medium might force a release. When you get enough mediums, then put out a release. 28 low, where we just fix it. The notification process seems to be working. It doesn't meet everybody's needs. There are internet companies that could reasonably claim that they should know. Sorry. We mostly met the disclosure and fix deadlines. We slipped on one time, and that wasn't because we were trying to get the right fix. It was because of manpower allocations. And when you're working with open source stuff, you tend to have interesting personalities, right? And so they'll just go dark. And you keep pounding and pounding and pounding on them, and then finally they'll wake up and go, oh yeah, here's the fix, here's the test, let's do it. Thankfully, we've had no critical yet. Critical is rekey the internet. The current GitHub activity, I'm just going to point out the highlighted thing at the end there, which shows, more in the past year and a half than almost the entire previous history. Excelsior, the New York State motto, onward and upward. Everything is done on GitHub now. Everyone has a CLA. We don't take contributions other than that. And the major technical debt has been and is being addressed. Native thread support. There's no reason to make it runtime switchable. The state machine that handles the protocol was greatly revamped. We don't do open coding of the TLS messages anymore. If you look at the current code, particularly in master, it'll look like a series of function calls that basically resemble the TLS presentation language. It also looks like the crypto bytes, and I forget the other data type in boring. The CLA flags have improved, the help has been improved, all the documents are improved. Our goal is to, within the next year, document every SSL function. Here's what's coming. The FIPS work is funded, but it's put on hold for TLS 1.3. TLS 1.3 is the focus of the next release. It is the main deliverable in the next release. It will be binary compatible with the 1.1.0 release. We have a contract, we, OpenSSL, have a contract, also we, Akamai, committing OpenSSL to a fixed delivery date. Part of the no surprises We'll have the details announced soon, but first quarter may be 4 months long. We'll have TLS 1.3 interoperable with Firefox, Chrome, Facebook, pick a bunch of servers. We're moving to Apache v2 license, hence the need for CLAs. We're doing more testing. We can already run the boring SSL suite. We're planning on adding the Kerberos test suite and the Python PY crypto test suite. We can run external tests as part of our stuff. Other things that should come, these are not in the public roadmap, but they need to be fixed. As I mentioned, the documentation, the random number generator. Anyone on Perry's crypto list saw a number of threads spawned by like, what can OpenSSL do in the real world? I don't care what the definition of entropy is. I just want to be able to generate stream of random bytes so that I can generate key material. There's almost an answer in there. We'll see. Generic store facility so that you can actually build a portable OpenSSL trust store and portably use it in all of your applications. We want to do that. With that, I'm just like 2 minutes over, so thank you for your time.